Welcome. Let's solve Leetcode 2054, two best non-overlapping events. Make sure you adhere to that. So they want us to choose at most two non-overlapping events. Please don't do the same mistake I did and try to maximize the number of events to obtain a maximum value that relates to as many events that a person could attend that do not overlap. Remember, we just want to attend at most two non-overlapping events. So I want to point that out in order for you to avoid the mistake I made. So we're given an events array, a two-dimensional list. So each of these inner lists represents an event. The first index for each event is the starting time. Second value is the end time, and the last value is the value that you would obtain for attending that event. And so in this case, I don't think the image is very good, but in any case, if you attend the event starting from 1 to 3, and then a second event starting at 4 to 5, you would receive both of those values of 2 and 2, so that's 4. And that's pretty much it. There isn't much else to the problem. So let's get started how we can do this. So I've provided an example here, so let's walk through it. So what we're going to do is first sort all events by start time, so that we'll loop through the events by the starting time. So these would be all of our events. So start time is 0, end time is 5, value is 4, so on and so forth. And what we'll do is we'll store and we'll have a queue or a min heap that stores the stop time and the value. So let's walk through this problem to see how that will aid us in finding our solution. Okay, so this first event here. So, sorry, and let me go over these two values here. So max value is the maximum or the event with the largest value so far. So let me just write that down. Let me see. Max value is the value largest value that has ended so far. So we could just put that here maybe. And max sum is can be the max value. Actually, no, it is. The max sum is the max value plus well, it's the maximum of just the maximum value plus, well, the maximum of is the maximum of at most two events. Is the maximum of at most two events. Now, why do I say two events? Because it's possible that I'll just do a quick example here. It's possible that we could have two events where one event it looks where they overlap, so there isn't you'd only be allowed to consider one event. So if you have one event here and another event here, and suppose you only have these events. So in this case, you would just simply choose the max of each of these. You couldn't choose two events because they all overlap. And remember, we're not allowed to visit events that have overlapping times. So that's why in this case you would only pick one event. So that's why it's very subtle to use this at most two events. So I wanted to point that out. Okay, so let me go through this example here. So first event here is 0, 5, and 4. what we'll do is um, we'll update the max sum, because there is no max value, meaning, because remember, max value is the largest value that has ended so far. So nothing's ended before this one. So we can only update the max sum. The max sum would be the maximum value so far. Well, sorry, the maximum would be the max of itself. So let's see that. So the max sum would equal the max of itself versus the max value, what I've seen so far, plus the current event. So current value. So the current value for this event is 4. The max value there is no event that happened before, so that means this would now become well, let me just leave it there for just so we can see it. So this max sum now becomes 4. And what we'll do is we'll store on the heap, we'll store the stop. We'll store the stop and as I mentioned here, we'll store the stop and the value. So the stop is 5 and the value is 4. And this will help us as we move on to other events, and it'll become clear later on. Okay, next event. So what we want to do is we want to look at any events on the queue that stop before this event starts. So this event starts at 3. This event stops at 5. So we can't use it, meaning like we can't attend both of them. So that's fine. So this stays on the queue. And then we try to we can't update max value because there are no events that happened before. So that's fine. So then we add this event to the queue. So remember, the queue would have the stop and the value. So the stop is the 8 and the value is 3. We can try to attempt to update max sum. So the max sum is max value, which is 0, plus the current value. The current value is 3. 3 plus 0 is 3, so we would not update max sum. Moving on. Now, this event says, hey, you finished. I can attend you. So it says, okay, I'm gonna pop you off the queue. But now I'm gonna say, okay, the max value is now 4. Because notice how from here on out, from all of these guys, from all of these events, any of these events can also attend this event. I hope that makes sense. Meaning that you can attend from here on out, this event and this event can be attended, this one and that one and this one and that one. So any of these events can leverage this event. So that's why I've updated max value. And so we no longer need to store it on our queue anymore. And we'll add this guy to the queue. So we add the stop value plus, the stop time, and then its current value. Then we check if we can update the max sum. So the max sum currently is 4, or the current max value, which is 4, plus the current value. So that would be 6. So let me go over that again. The max value is 4, and the current value is 2. And that makes sense, right? Because I can attend this event, which ends at 5. This event starts at 6, which is right after it. So I can attend both of these, which makes it a 6. Okay, great. Moving on. This event, 7. So this event starts at 7, but this one ends at 8. So this event says, how many of you, so on the queue, have ended before I start? And none of them have. So we don't update max value. So that means we just add this guy onto the queue, this event onto the queue. So we add the stop time and its value, and we can attempt to update the max sum. So the maximum of itself, or the max value, which is 4, plus 3, which would be 7. So yes, we can update it, so this becomes 7. And let's think if that makes sense. Well, I can attend this event and that event. That would be 2 plus 4, which is 6. Or I can attend this event and that event, which would be 7. Just considering these 4 events. So yes, the max sum is 7. Okay, great. Moving on. Sorry. Yes, moving on. Now this guy. So here we are. So this event is going to say, okay, which of you on the queue have finished before I started? And so all of them finish before he starts. 8, 10, and 12. This guy starts at 13. So we need to look at them individually. So we're going to pop this guy and say, okay, well, let me look at you. So remember, this means that because it's before, let's see what the max value is. So remember, we're only comparing 2 events. So it's crucial that we look at all the previous events and see which one is the biggest. So this is 3. The max value is 4. So we don't need to update max value. But we are going to pop it though. We don't need it anymore. 2. This event is worth 2. The max value is currently 4, so we don't need it anymore. This guy is 3. This event is 3. The max value is 4. We don't need it anymore either. So we don't update max value. Now, so here we have this event, which is 2, and the max value is 4. So we can add, well, so that would mean this is 4 and 2, which is 6. That doesn't affect the max sum because the current max value is 7. But we could add this onto the queue. However, it's not going to be important because we've run out of events, so that's fine. So we could just do it for completeness. So the ending time is 17, and its value is 2, and so we arrive at the answer is 7. And so let's go over if that makes sense. Well, sure it does. So it looks like this one had a value of 4, and we can attend this one here. So this is 3 plus 4, and that's 7. If you add any other 2, we don't get any if we had any other 2 values for events that do not overlap, nothing is higher. Like for example, we could attend this event and this one, but that would only give us 6. So this is how we're going to solve the problem. I hope that makes sense. And let's comment this out while we begin. So remember, we only need to compare 2 events, not all of the events. That's the wrong problem I was solving earlier. So let's set this up. So what we'll do is we'll do let me see. We'll sort the events. Events.sort, and .sort automatically sorts them by their initial value, so the start time. I will create a heap or a queue, and I think, well, let me give you some space, you can see this better. So I think we can start here. So so we need to initialize our max value and our max sum. Sum is like just the total between the 2 events, or max of 2 events, at most 2 events. And then now we loop through all of the events. So I'm going to say start, stop, and value in events. And then what we do is we look at the values. Remember what we did here? We say, okay, how many view events on the queue have stopped before I started? So let's do that. So while queue and queue. So the first node on the event and this is the stop value. How many view? This is the stop Let me just write this down real quick. So remember, the queue is holding our stop value and our just value, our stop time and value. So how many of you guys on the queue, how many of the events on the queue have stopped before I started? And if you have, we attempt to update max value. So max value would equal max of max value compared to the event on the queue and that value. And otherwise, we just pop that event from the queue. Queue. Okay. And now we attempt to update the max sum. So the max sum would equal max of max sum, as we did up here. Remember, we did basically this here. We can just maybe copy that if we, no, that's fine. So the max sum would be the max value so far. This is the event that already finished, including myself, or the current event, which is this guy. And lastly, I think we just need to add this current event to the queue. So we say heap push onto the queue. Remember, we're storing the stop value, the stop time, and the value. So the stop is stop here, and the value. And then I think we just return the max sum. And let's run that. Let me see if I made a mistake so far before I do that. It looks good. So let's try it out. Okay, it looks good. And let's submit it. I may go over an optimization if this looks not bad. So 94%. All right. So let me just go over a small piece of something here. So this is fine, right? There's nothing wrong with it. So, and there isn't. This is just, it's perfectly fine. But one thing as a developer is that if you're looking for maybe some optimization or just some improvement, sometimes you can consider removing unnecessary functions. For example, we use this max because it's, maybe some consider it Pythonic, but it's also clean. It makes the code look clean. But suppose we removed it. Suppose we said if this thing, the current value is greater than max value, then we just set max value to that. So now we've removed a function. So this is the function call. So we removed a function. Now we're just dealing with memory. Same thing over here. What if we convert this to if max value plus value is greater than max sum, then we set max sum equal to max value plus value. So again, we've removed two function calls, and now we're just dealing with, this is just a comparison, and you're just assigning a value to another value, and this may or not improve it at all. It may maybe even reduce it, but I just wanted to point it out to you. So it's something for you to consider. So I don't remember if this was, let me see, is this better than the other one? Yeah, it is. So remember, the last one was 131 milliseconds, and this one is 97. So again, I just wanted to point it out to you that sometimes removing like these function calls, in my opinion, function calls, or not even my opinion, but some function calls can be more expensive than just doing a simple comparison. So that's one thing I wanted to point out to you. All right, if you like this, or it was educational or helpful in any way, consider please subscribing and give it a thumbs up. Have a wonderful day. Take care.